Hey guys, so what we're going to do today is we're going to tackle a potential divider question. So I don't really like calling them potential dividers because most people, they hear those words and think it's going to be really hard, but it's actually a really nice question. But I get a lot of problems, a lot of messages about this, so that's why we're going to tackle this question today. But before we get to it, I want to do a quick brief overview of electricity and how A-level is built from GCSE. So electricity. We all know that it's got to do with circuits, right? And everyone's pretty happy that once you get to your A-levels, that this is a cell, and our cell always gets connected to something like a bulb. We have an ammeter that is in series, and then we have a voltmeter that is across devices that measures the potential difference. The key thing is you need to start calling this potential difference. So PD for potential difference. Because what a voltmeter does, it tells us the energy difference, the potential stands for energy, the energy difference between 2 points on a circuit, okay? And the definition that you need to know for that, it comes from our equation E equals VQ. So if I look at potential difference, what it is energy transferred per unit charge. So what a voltmeter tells me, it tells me the energy transferred per unit charge between 2 points in a circuit. Okay, so that makes sense. So if this bulb has a really high resistance, it's really hard for the electrons to get through. That means that the electrons are going to lose loads of energy going through it. So the energy transferred per unit charge trying to move through it is going to be really high. But if the resistance is really low, it's really easy for the electrons to get through. They don't have to lose much energy getting across it. So that's why if the resistance is low, the energy transferred per unit charge will be low and my voltmeter reading is low. The other thing you know about voltmeters is voltmeters technically have an infinite resistance. So what that means is when my electrons are flowing through my circuit, they are never going to go through the voltmeter. So the voltmeter just measures the energy difference of a unit charge at this point versus this point. It tells how much energy was transferred, how much energy was lost on going through that bulb of a unit charge. And in our ammeter, the definition you know for an ammeter is we know the equation for an ammeter is Q equals IT. Okay, the way I remember it is the Queen is the it girl. The Queen was in charge of the country, so Q stands for charge. So to find what the current is, I can see it's Q over time. So what an ammeter measures, it measures the rate of flow of charge because 1 over time becomes rate. So what the current, the definitions for a current or what an ammeter does, it measures the rate of flow of charge. Okay, the rate of flow of charge. And an ammeter, technically its resistance is always 0 because we don't want the electrons to lose any energy and going through it. We don't want a unit charge to transfer any energy on going through that ammeter. Okay. The other equations you need to know for this topic is V equals IR, which tells us the potential difference is the current times the resistance. You need to know power equals I times V. Power is current times voltage. And the last one is power is equal to I squared times R. Power is current squared times R. And this equation you mainly used in GCSE and you'll use in A-level tells us about the energy lost through the cables when we're transferring from a power station to your homes. So what happens then, that's why we use those step-up transformers, because a step-up transformer is going to increase the voltage. And the reason that we increase the voltage, if I make the voltage super high, what happens is the current can become really low. So the voltage becomes high, our current becomes low, which means then that if the current is low, I'll have less power losses due from the cables, less power losses due to heating, from me transferring the energy across the UK, across the national grid. Okay, other things we need to know, tackle this question. We need to know why a thermistor. So a thermistor has got a negative temperature coefficient. You don't really need to know that. You just need to know that in a thermistor, if the temperature is high, the resistance is low, okay? And these are made of things called semiconductors. So you've probably seen semiconductors before in your periodic table. In chemistry, you always divide your metals and your non-metals using that little dotted bridge, your metals and your non-metals. And your semiconductors are just on this bridge. They're things like silicon and beryllium, Ge. So what semiconductors do is that when we increase the temperature, when I increase the temperature, I'm moving more electrons into the conduction band. I'm freeing up more electrons. That means I've got more electrons to move and carry charge, which is why the resistance goes down. So they become more conductive in a higher temperature because we're giving energy to the electrons to free them from the valence band into that conduction band. And the valence band is just what we call that outer shell of electrons. Okay, so over here, I want to calculate the current. To calculate the current, the first thing we're going to do is use this equation. So to calculate the current, step A, what we're going to do is V equals IR. So I know the potential difference of my cell is 9 equals my current times by my total resistance. They're in series, so we just add them together. So 60 plus 120 gives me 180. To find the current, what we do then is 9 divided by 180. So divide both sides by 180, and we do 9 divided by 180. We can figure out our current is going to be 0.05, and current is always measured in amps. Next one is calculate the voltage. Again, we're going to use our equation V equals IR. So to calculate the voltage, I know the current through it because it's a series circuit. So that means all the electrons, the current is the same everywhere. Because remember, a voltmeter has infinite resistance, so no electrons pass through the voltmeter. They all pass through both resistors. So the current is still 0.05 times by the resistance of R2, which is 60. So in your calculator, we do 0.05 times 60, and we figure out that our potential difference there is 3 volts. Okay, the last bit here is it's saying that R1 is now changed to a temperature sensor. So it's changed to a thermistor. So what I'm doing is I'm going to change R1 to a thermistor. And we know that for a thermistor, when the temperature is high, the resistance is low. So what it says here, we want to decrease the temperature. So if we're going to drop the temperature, it does the opposite to what we just learned. If we drop the temperature, the resistance gets much higher. So it's asking us what's going to happen to our reading on our voltmeter then. So if the resistance here gets much higher, that means if we look at our total circuit, the whole circuit, we've increased the resistance. So for part C, the resistance of the whole circuit has been increased. So if I look at my equation V equals IR, if I've made the resistance of the whole circuit much bigger than 180, what that means then is that my current value is going to end up being much lower. So because the resistance increases, the current decreases. So now, if I'm trying to figure out what's happened to this voltmeter, remember we said what we're doing here is V equals I times R. Yes, the resistance of R2 stays the same. It's still 60 ohms. But what we've done, remember, if we've decreased the whole current, so the current is much lower now than 0.05. So if we've dropped the current, what that means then, if I look at my reading for voltage, that voltmeter is going to decrease. Okay, so again, quite a nice question when you think about it, but it's just the word potential divider throws people. So if you liked the video, just remember to like and subscribe and share it with your friends, or comment below any more topic questions you have.